So in the last class, we done till the isosceles triangle. Now in this class, we are going to study Pythagoras theorem. So Pythagoras was the name of a mathematician, and he made a theorem to find the to get a relation between the base, altitude, and hypotenuse of a right angle triangle. So what is a right angle triangle? A triangle who consists of one angle as 90 degree. So जिस triangle का एक angle 90 degree है, that is an right angle triangle. The side which is on bottom, this is the base, and the side which is vertical, the vertical side is altitude, and the longest side is hypotenuse. So what he did, what the relation he gave is, if we take the square of base plus square of altitude or altitude, whatever you want to pronounce it, is equal to square of hypotenuse. That means this side. So this was the Pythagoras theorem, which is applicable only for right angle triangle, and it gives the relation. And this b square, a square, h square is the length of base, that is AB, the length of altitude, that is AC, and length of hypotenuse, which is BC. Okay. So what it says that in a right angle triangle, the square of hypotenuse side, the square of hypotenuse side is equal to the sum of square of other two sides. Sum of square of other two sides, that means base and altitude. Okay, so this was Pythagoras theorem. Now let's see some questions based on Pythagoras theorem. So what was the history? Mathematician Pythagoras, a Greek mathematician, Pythagoras named this theorem. I also told you the formula: hypotenuse square is equals to perpendicular square plus base square. Now let's see some examples. So this is the example number 1. So here we have base as 8, altitude as 6. So what will be the hypotenuse? So by the formula, x square will be equal to 6 square plus 8 square. Now you guys calculate what is the value of x and tell me. Tell me what is the value of x. Who's now? Manan, Mehak, Sahil. Calculate the value of x and tell me.
Okay.
Is anyone telling something? Mehak, Husna, anyone?
No, ma'am.
Yeah, speak up. Calculate it and tell me. Do
Ma'am, I can tell, ma'am.
Mehak and Husna, are you able to see the screen? Manan, what did you say? Manan, what did you say? Come up again. $100. No, it is not 100. See, it is x square. You have to find x. That means for finding x, you have to take the square root of this thing, which is 100. So you have to take the square root of 100. Okay, which is going to be 10. If you know how to find square root. Now, Mehak and Husna is having internet issue. Okay, guys, if you are able to see the screen, then continue. Otherwise, I'm recording it and I'll send it. Now let's move to our next topic, which is symmetry. So this topic is not that important, and also it is not consisting of many things. So symmetry in mathematics. So in mathematics, the meaning of symmetry defines that one shape is exactly like the other shape when it is moved, rotated, or flipped. So when one shape, let's suppose this side is exactly same as this side, this is called symmetry. Okay, and the line which is dividing it into these two shapes is called line of symmetry. Okay, so like if we take heart, if we draw heart, then if we take this line, then these two parts are equal. In my figure they are not equal because I drawn it with my hands. So if we draw heart, these two sides are equal. That means this is symmetric, and the line which is dividing it is called line of symmetry. Understood? Understood? Okay. So symmetrical figures. Now comes to the figures that are symmetrical or shapes that are symmetrical. So let's see. So these are some examples of symmetry. If you see how this figure is symmetrical, let's start with this part. If you take a line here, then these two parts are exactly same. They are same, right? If you take a line here, then these two parts are exactly same. That means this figure is symmetric. Similarly here, if you take a line here, then these two parts are exactly same. That means this is symmetric, and this is our line of symmetry. Now see these figures and tell me what is the line of symmetry. Where should I place the line of symmetry to get a symmetric figure? And is there only one line? That means there is only one line of symmetry, or there are more than one line of symmetry. So see the figures and tell me that there are only one line of symmetry or more than one line. And if there are more than one line, then how many lines will be there for C and D part? See and tell me. So Manan, did you for C part? Can you tell me how many lines of symmetry we have? Manan, am I audible to you guys? Hello, Manan, Husna, Sahil. Hello. Okay.
Yes, ma'am.
Okay. So tell me how many lines of symmetry we have in this figure.
Ma'am, we can make in this one, ma'am.
We can make this one, but from other side we can also make this one. We can also make this one. So there are 3 lines of symmetry here. Yes or not? So there are 3 lines of symmetry here.
Yes, ma'am.
Similarly for this, we can make a line from here. Can make a line from here. So these 2 lines are making it symmetric. Okay. So it have 2 lines of symmetry.
Okay, ma'am.
Ma'am, for this also we can make, no? For this one, no?
Yeah, we can make for this one. Yeah, we can, but I'm trying to explain you through this and this figure. So isn't this, if it's through this and this figure, I just want you to understand what is line of symmetry and how can we say that it is symmetric. So if the 2 halves are same, like in this case and this case, then it is symmetric. Okay. Similarly for this, you can identify the lines of symmetry. So you can like do it on your own. You can identify the lines of symmetry and how many lines we have. Okay. Now move to next part. So this is the like earlier figure, which is they have shown us that how many lines of symmetry we have. So we have 2 lines here. So what is line of symmetry? So the line that divides the figure into 2 halves, 2 symmetrical halves, that means 2 equal halves, is called line of symmetry. And that line is not real. There is no real line. We are just making a line with using dashes. So a dash line. So this kind of dash line is called imaginary line. Okay, so this is called imaginary line. Okay, so the imaginary line or axis along which you fold a figure to obtain the symmetrical halves is called line of symmetry. Okay, and these 2 halves are mirror image of each other. Okay, now move to these are the lines of line of symmetry. Now let's come to lines. Lines mean when there are more than one line of symmetry. Like in this case, there are 2 lines. If there are 3 lines of symmetry, like in this case, 4 lines of symmetry for this case, and infinite lines, like for a circle, we can draw any number of lines to get a symmetrical shape. Okay, so for a circle, there are infinite lines. Okay, so some figures have not 1, 2, but infinite lines that makes the figure symmetrical. Now comes to the types of symmetry. Okay, so symmetry may be viewed as when you flip, slide, or turn an object. There are 4 types of symmetry that can be observed in various situations. There are translation, rotational, reflection, and glide symmetry. So let's first see translation symmetry. So if the object is translated or moved from one position to another, the same orientation in the forward and backward motion is called translational symmetry. Okay. In other words, if we define as this sliding of an object about an axis, let's suppose this axis, and if we like slide it along this axis, slide it means move it along this axis, then this kind of symmetry is called translational symmetry. Okay. Just for an example, if we have a shape here, like a square here, if we move it backward, that means forward, that means this side. Okay, my figure is incorrect. Or this side, it will remain same. The shape will remain same. So this kind of motion along a line or along an axis of an object, which results into the shape of the same object, is called translation symmetry. Okay. Now come to the rotational. In rotational, what we have, if we rotate a figure by certain angle, like in case of a square, if we rotate it by 90 degree, then we are going to get the same square again. If we rotate it again by 90 degree, we are going to get the same rotation, the same figure again. So this kind of rotation is called, this kind of symmetry due to rotation is called rotational symmetry. For reflexive symmetry, if the one half reflects the other half, that means if we are having this half and it is reflecting the other half. Reflecting means if we take a mirror here, if we imagine a mirror here and we have this half at one side, then the mirror will show this half. So this kind of symmetry is called a reflexive symmetry. Okay, where we imagine a line of symmetry as a mirror, and whatever the shape which we have this side, if it is obtaining like a mirror image at this side, then it is called reflexive symmetry. Okay, other types of symmetries are not that important, like glide symmetry. So if translation and reflection both are there, that means this one and this one, if these both are present, then it is called glide symmetry, which is not that important and maybe it will not be part of your exam as well. Now I've already shown you symmetrical shapes Now come to the solved examples. Okay, so in the first question, if the figure below follows a reflexive or a line of symmetry, then completes the figure. Okay, so for reflexive, we have to complete the figure. So in case of reflexive, whatever we have, the mirror image of it will be on other side. So we just have to draw its mirror image, which will look something like this. Okay, and it will like come up like this. Now identify the image which do not follow rotational symmetry for the following figure. Okay, so first one, if we rotate it by any angle, will we going to get the same shape? No. If you rotate it by any angle, you're not going to get the exact this triangle. So this is not part of rotation. If we rotate this side, that means this vertex to this point, that means if we rotate it by an angle of 120 degree, then we are going to get again this shape. So this follows rotational symmetry. Similarly, if we rotate it by any angle, rotation means you can like imagine it that you are moving it on the side of a circle. If you move it, you are not going to get the same shape if you move it. Okay, so this is not following rotational symmetry. And with rotational symmetry and its examples, this PDF is over. So one of you have any questions related to any part of this symmetry? What are the parts of symmetry, rotational, reflexive, anything, or any doubts from the earlier class where I told you about median, altitudes, exterior angles, interior corresponding angles? So you can ask me. Okay, and if you're not having doubt, like if you want to go through it once again, you can go through it. Yeah. Anyone saying something? Speak up. If you have any doubts or any questions, ask.
Okay, ma'am.
Yeah.
Okay, ma'am.
So it must be clear to you. It was not that complicated topic. It is just that you have to go through it 1 or 2 times.